Welcome to the Structural Engineering Podcast. This episode will be the kickoff to our Louisiana Pacific series. Not too long ago, Zach and I got the chance to visit LP at their office in Tennessee and talked with a number of people from multiple sides of LP's expertise. We tried to learn as much as we could from those conversations and figure out how we can use the knowledge and experience at LP to be better structural engineers. This first one will be off our normal structural specifics, but completely part of the building big picture. We're talking with Neil, a building scientist at LP, about what on earth a building scientist actually does and what he does at LP, and most importantly for us, how structural engineers can do our job better from a building science perspective. So please enjoy, and as always, let us know if you have any questions at all.
I'm Neil Freidberg. I worked for LP for almost 3 years now. My background is building science. But before that, I have a degree in architectural engineering. So I graduated from Texas A&M, Kingsville. I come from a construction family. My brother had a business, and from the age of 12, I would work for him on summers or some weekends, depending on, kind of how mad my parents were going to be at me. You know what I mean?
Yeah.
So it was great getaway. And I was like, it's funny because my background in construction is, I don't want to do like the physical labor. I'd rather, be like an architect. I'd rather go design it, because I was on a couple plans where I'm looking at these plans and I'm like, this guy drew terrible sets of plans. He's an architect. He obviously has a degree. I'm like, I could do it. If he can do it, I can do it, right? That's kind of like my background, like why I got into this. And then as I got older, I realized that I don't always think pretty. So I went engineering route, right? I was like, no. And then I was going to go civil. And then I found architectural, which is kind of like a hybrid of both, right? Architect, where you get to kind of work with and design a little bit. Mechanical MEP around like HVAC systems and stuff like that, but then also structural design. And it was like these weird hodgepodge, right? I was kind of like the 8th person to graduate from the program, because it was fairly new. So that's kind of what led me down to this. And then I graduated in 2010, peak recession. And I was like one of 8 people graduating of the 80 who actually had a job leaving college. So I didn't go get my doctorate, like my master's. I was like, I can't afford that. Like, I got to go make money. Yeah. And luckily, like Owens Corning hired me, and it was a lot of trial by fire. They'd be like, go do this, go do that. But in the meantime, I'm learning more, educating myself, and then became kind of an expert on air sealing, how air moves, how moisture moves, right? Now, I'm not a doctorate. Like, I don't have a doctorate degree, but I could argue with most of them. Like, you know what I mean? Like, they'll probably beat me under the table, but I can hold my own for a little bit.
Yeah. And so the first position was very building science, leaving with an architectural engineering degree.
Yeah.
Structurally, I think of a very specific.
Kind of. So I started with like helping repair machines. And because we developed an air sealing method at Owens Corning with a gasket, a spray material. Ended up being more of a repairman. But during that time, my boss would be like, hey, go learn WFI, so a hydrothermal modeling software. And then, because I'm a bit of an autodidact, I like to teach myself things. I taught myself how to do CAD. I taught myself how to use Revit, SketchUp. Just kind of, because I got bored, right?
Yeah,
So,
I would assume there's a lot of extra learning in building science.
Yeah.
Outside the architectural engineering degree.
Yeah. And then what's even crazier is Owens Corning almost never told me no, which is great. Like, I really appreciate that. Because like if a builder had an issue, it's like, hey, look, we're having high moisture issues in our buildings in Texas. I'm like, all right, well, let me go find the root cause. And I found out that they were oversizing their HVAC system. So I'm like, okay, well, I have some history in HVAC, undergraduate, very high, very low level. I went to, I took courses on manual JDNSs. So I've learned how to like actually size units. And I started learning that really depends on the envelope, right? So it became much more of a good story for me, because the envelope that dictates how moisture travels in and out of the building, and then the HVAC system, how it controls it internally or what it does when it's inside, kind of led to the story of the whole wall performance in whole buildings. And then it led to that energy portion of my experience, where now I understand how to save people money, like via energy savings and stuff like that. This is weird hodgepodge history of me.
Okay, so I think my first formal question, I want to define building science in my head, right? So I think building science as this very important topic that is hard to put a name to. Well, how do you define building?
It is, and it's funny because just a couple of days ago, I was joking with my wife. It's like, I feel, I guess what a doctor would feel, right? When you go to a doctor, be like, hey, something's wrong. And he kind of understands a little bit of everything and says, oh, you may have high blood sugar, or, whatever the issue is. I'm like a doctor for homes. Like I can walk around and be like, oh, look, there's moisture here. It's probably an issue inside of that wall, or it could be a window detail. I'm like, I kind of like that. You know what I mean? And so to make people happy at a party, I'll be like, yeah, I'm basically a doctor for homes. Like, a doctor tells you what's wrong with your body. If you're not feeling right, I can tell you what's wrong with your house if it's not acting right.
Yeah.
Or moisture's appearing, right? That kind of thing. But like on a real level, it deals much more with understanding the transient properties of where vapor comes from, how it affects the use of the building, and then the occupancy or even the use of that, right? So like if someone said, hey Neil, I need you to run an analysis on this building, great. Does it have a gym? Does it have an indoor swimming pool, right? Because all those things really affect how the envelope's going to perform. So like I've consulted a bunch of places. I've consulted with people in China because they have basements and they have a much higher humidity than we do, period. With people in Saudi Arabia where they're just looking for energy savings in cooling.
Yeah.
And like people in Chile who's like trying to air seal buildings, but they have like a Seattle kind of climate. So it kind of just depends.
So what do you do at LP then? What do you do at LP?
So my job specifically at LP is I wear a couple hats. So I manage our lab that does a lot of experiments. So a lot of the new product development that we're dealing with, especially on the structural side, comes from my lab, or it works through my lab to where I manage what tasks we're doing, what tests we're doing, stuff like that. But then I'm also working on how to apply, our tape better. So I've come up with a couple inventions that we're patenting. I'm coming up with this, I can't say too much, but like a cool backpack that can apply something. Like, we're Scott and I are going to be working on a couple patents together. So it just kind of depends on what's needed. Like, and sometimes it's, hey, I need you to be the final voice for this customer, like a big customer that's starting to jump on our product and says, hey, it would be great if the building science guy is there to help them walk through any potential issues. And I've even gone to builders' homes, like the ones they're building, and be like, hey, I can see potential moisture issues here in the future, and here's how to avoid them, stuff like that. So kind of hodgepodge consultant work, but also, deliverables, but then I also manage a group of people. So it's kind of depends on what they need.
Are you working then with architects as well, with their detailing? And
at Owens Corning, I used to be much more involved in that. I was part of the AEC group there. So like I would go and work with architects. They'd send me their details. I would make sure that their building wouldn't grow mold.
Yeah.
So if you're on the design front, not just like walking the building, you see an issue.
Yeah, correct. Yeah. So at Owens Corning, I was like a little bit more like 75% residential, 25% commercial. Here, it's like 95% residential, like 5% commercial. But really, the commercial ends up falling more on like Scott's shoulders than mine. But yeah, it just depends, right? I tell people I just like to solve problems. They're puzzles, and I'm good at solving them for whatever reason.
I would assume that houses tend to have a lot more issues since the construction can be variable.
Yeah.
There's a certain set of people that do commercial construction, and they're very good at it. I've built houses and I'm terrible at it. So I think, the people that are in that category are not always the best. Yeah.
Well, it also depends on their experience, the trades, the product development, right? So like if they're using new products they're not comfortable with, it all just depends. I've learned that regardless of people's experience, if they're willing to learn and do better, they tend to, right? They want to prevent issues in the future. And especially when it comes to like residential versus commercial, it's the ownership of the building, right? I have to sell the owner, but I also have to sell the architect. I have to sell the guy who's writing that CSI spec to make sure that we're doing something right commercially. A builder is much more mass production, right? So like I got to sell him it's like, hey, this is going to solve a lot of issues, but let's also focus on the ones that matter, right? If we're doing this, we should also look at this. Over here, you have to have in mind in the commercial realm, you have to have in mind the fact that my one change can change the whole scope of the project.
Yeah.
And so I have to be super careful and much more diligent, right?
So from like your experience in like the AE industry, working directly, when do you get involved on a project? Is it day one?
No. So typically mine is more when they're speccing products that I come in, sometimes the bearer of bad news and say, hey, the one that always hits me the most was I got called into a project that was already in motion and they were building and they started having moisture issues. Well, I show up, right? Because I'm on site. I'm just trying to figure out, I'm looking at their plans and it didn't click, but they had a garage connected into the structure of the first couple of floors. Well, they were having a lot of moisture issues. Well, it's concrete. Concrete is cementitious, it's porous. The water was basically pouring in from the parking garage through the column. affecting the comfort of the building on those couple layers, on the couple floors, right? So like then I learned, it's good to have some sort of capillary break, right? So it's a combination of like, I stumbled across a solution or I got lucky and I figured it out. But yeah, I mean, it's kind of those things where sometimes I'm too early, but I help guide that process. And sometimes I'm the guy giving you the bad news and being like, all right, you guys have to find someone who can fix it because I'm not a consultant, right?
Yeah.
I'm typically a manufacturer. I work for manufacturers, so I can't provide here's a solution, here's the step-by-step process. It's like, hey, here's your problem. Go hire that person who's going to give you that solution.
Yeah, cool. It really does seem like it's just pure problem solving.
It really is. Yeah.
That's so cool.
So yeah, diving into the problems you see, like what do you have, like a handful of issues you run into or that are common? I mean, you talk about moisture and things like that, but
yeah. So like I'll start residentially. Residentially, one of my biggest issues is people tend to oversize their HVAC system, right? The more energy efficient homes are becoming, the less HVAC systems actually have to be, right? The less the size, because you get what's called short cycling. That's where you super cool a building, but you don't have time enough to remove that humidity in that space. Because you typically have one set point residentially, right? So it's temperature. And what it does is it'll hit that temperature, but it doesn't have enough time to remove all that moisture. So what people do, they become uncomfortable. They tend to lower the temperature so that it allows it to run longer to then pull out that moisture. So if it was done right from the beginning, it would prevent issues. And that leads to, then that moisture has to go somewhere, right? Is it through the walls? Is it in the crawl space, basement, slab, right? So it kind of cascades. So residential is actually really easy because you have one user and one expectation of comfort. Commercially, we fall under ASHRAE standard 55 and 60.1 for comfort and the PMV of how, like, I'm comfortable in this room, but I know it's kind of chilly, right? So you guys are wearing long sleeve shirts, so you guys are probably more comfortable than me, right? And that affects it because the people here in this office can't change the HVAC system. Like we can't, like they have a 2-degree set point change, but it's a false 2 degree. It makes you think that you changed it, but it doesn't do anything.
Yeah.
Because the facility engineer doesn't want you to have control.
Yeah.
Because if it would, it'd be up and down. Systems would be cooling some days, some heating, right? So it'd be random. So those are much easier to control, but you disappoint a lot more people. You know what I mean? Like,
something I found out a couple of years ago, I thought was so interesting is most thermostats in commercial buildings are fake.
Correct.
I never realized that. Actually.
Yeah, they have that false 2-degree set point where in your head it's a placebo effect. It's great.
I feel warmer now. I moved.
Yeah, 100%. And me, because I know that fact, I know that they do that, I'm uncomfortable whether I change it or not. Like I have to basically take it off the wall, disengage that setting, and then actually change it myself. And I don't want to tell people in my office I know how to do that, right? Like,
I've heard that some walk signals to cross the street are like that. I heard that when I was a kid, but like very infrequently, like some that are just on every other cycle. And so the button is there to make someone feel like they did something, but it's just the same cycle every time. So no change.
It's funny because, and then when I tell people around me and I'm like, they're like, they're like, oh my God, it's hot. And I'm trying to put it down. I'm like, it doesn't work. Don't worry about it. Like, it's not going to work. Trust me. But yeah, so it's real funny. I've used this metaphor before, but you guys seen The Office, right?
Yeah.
You remember when Robert California had a party at his house and Dwight was walking around looking at the cabinets, opening, closing doors, going, oh, this is good construction. Like, I'm that guy. Like, that's what it comes down to. I'm that guy.
Good goal. Be that guy.
I can see the thumbnail of our podcast now as your face over Dwight.
Okay, so this podcast, we mostly talk to structural engineers. So I want to sit in that category for a little bit. Structural engineering details. What do you see that we could fix the most, basically, from a moisture moving through? What can we do to improve ourselves here?
That's a great question, and I have plenty of examples. So when and this isn't my example, but this is an example I'm going to take from somebody who showed me what the issue was, and I knew how to fix it, and he knew how to fix it, but the structural engineer said, nope, we can't do that. So they were dropping piers right along the coast, right along the river in Boston, right by the river. and they're dropping these piers in, and it's basically underground and sitting near or close enough to water. Well, the recommendation is, okay, how do you waterproof it, right? Well, the idea would be to put a thin layer of some sort of tough poly just over that seat. Well, the structural engineer said, no, we can't. We have to have full contact. Like, can't be done. So now we have to modify the waterproofing detail around it that isn't going to be as great, right? Because we were at a point where we could put it in there and then they can build that next footing right on top of it.
Yeah.
But the engineer was like, nope, it has to be there. So that literally in the future could be a potential path for moisture issues. So in my only suggestion is, if it can be continuous and it has to be, we all get it, right? Structure and safety over anything else. But if at any point there's a break where you can install some waterproofing, some barrier that helps prevent future issues down the line, do it. Just keep that in mind. You know what I mean? Like, no different than breaking adding a capillary break between the parking garage into the structure of the building, right? They do a great job of focusing on the envelope, but they don't look at those parts that allow for moisture to path in, or find an issue with when another one of the issues I was involved with was moisture dripping inside of an in-ground parking garage, right? They're like, oh, well, we put insulation up there. It shouldn't get this way. And then you go and find out that they never put any waterproofing over that concrete. So as it rains, it percolates down because of gravity, ends up in the insulation, and they're blaming a product for causing a failure where they missed a waterproofing opportunity, right? Like, where they could have put some sort of layer, some sort of rubber skim, even coated it. And that's what we ended up having to do. We ended up having to put some sort of rubber tack, and it got rid of the moisture issue, right? But it's more about concrete can carry water, right? Water can climb up to like 35 feet in those micro pores, right? So like, just keep that in mind when you're building. Like,
is there a good reference for details that are done well for capillary breaks and water moving through? Anything that we can look at as a good example?
Yeah. So to be honest with you, I haven't seen any. And I think it's a failure on the manufacturer, mainly because it's a little bit in that, are we providing a product solution that they can design with, or are we designing for them? And that becomes the issue, right? Who's going to take on that liability if I give you the design as a manufacturer, but I have no skin of the game besides this like less than 1% of the building's cost product, right?
Yeah.
So it's just one of those things that it just depends. There are a lot of consultants who like live and die by this, right? Like, you're talking to me and I dabble. There's people who live this every day, right? And they're amazing people. I know some of them. And they deal with it, they find solutions, and I get to live vicariously through them because we update each other, right? We know some things, we share ideas, we share concepts, but manufacturers are tough when it comes to that. Yeah. So it's hard, but it's not hard if you work with a manufacturer. Like, let's say you trust a manufacturer and say, hey, look, we have the situation, this is kind of the detail we're putting. Where would you recommend we put your product, and why, right? Like, always ask why. Never just accept, here's the answer. Like, ask why. Like, it makes sense. Like if they say, hey, I believe this because the footings are in water, like, it's going to pull water up, right? That makes sense. That's good. Or if you're in Arizona and they want you to waterproof the base, why, right? Yeah. So it kind of just depends.
Okay, that makes a lot of sense. So structural engineers, we follow a lot of code books.
Oh, yeah.
We have way too many. But we have just the right amount. But when it comes to building science, like, where's your reference material? Where do you point to when you're looking at these types of things?
Yeah, so that's a great question. A lot of it is out there, whether it be articles or updates or failures. I'll be honest, some of it's gut instinct. You know what I mean? Like, it's as bad as it sounds. There's no one says, hey, moisture is going to climb up this pillar versus that pillar because that one has a coating, this one doesn't have a coating, right? Like, it's kind of a shot in the dark. So we treat everything the same. We're like, okay, we're going to treat everything as a potential failure point and then go from there. So as far as like, where do we learn? A combination of experience, knowing how materials work. And then, there's not a lot of building scientists who deal with this every day in the US. It's funny because I go to a lot of these conventions and it's like, oh, hey, Bob, I saw you last week at the other one that we went to, kind of thing. You know what I mean? So, but there's a lot of people who put out wonderful information. Building Science Corp is great. Joe Steebrook and has his group. They do amazing stuff. They consult construction instruction. They're more residential, but they consulted for commercial products, I know. And then, of course, you're going to find anybody in that realm that have like their own little private groups. But yeah, I mean, RDH, there's a big one, WJE. If I, people know when I say WJE or RDH. But yeah, so like they have their own building science group in their facilities, right? So that's who they pull to.
Okay.
So it's just one of those things, like it just kind of depends.
Yeah. So is there like does the building code require you to look at things from a moisture perspective, like because of longevity, or is it more like you got building scientists who are kind of more coming in on the back end as a forensic side of things, trying to solve the problem? So
that's how it started, but now we have standards, right? So like there's modeling standards for mold and moisture. So through ASHRAE SSPC 160 tells you how you're supposed to model a building for moisture, how long. Right, it gives you the parameters. It doesn't like specifically call them out because there's a lot. You have to be kind of broad because there's other programs that exist besides one particular one or another. There's so through ASHRAE, a lot of building scientists are there, right? So even though they may not be as like detailed as me, they may be deeper in it, where they're focusing on the product and the capillary effect or like the transient properties of a material or paint, right? They're still building science, right? So, and mind you, in my opinion, anybody who puts a building together is in that realm. Like officially you're in the realm, because when you start building those systems together, you have to kind of understand like, okay, well, does this curtain wall system allow for ventilation under areas that aren't seen? Or does this double facade work in this climate zone, right? So you have to start thinking of these things and how it's going to affect the structure. Are my bolts going to have to be zinc versus stainless steel versus, like these things, like you guys think about it, whether you believe it or not, because that, okay, in this climate, in this area off the coast, I have to focus on this. In this area inland, I have to focus on this seismic, right? So like there's building science everywhere, right? I'm like 1% of a crazy group of people that happen to be more specific, but like everyone is in building science.
Yeah. I was definitely an aside sort of question, but since you mentioned modeling a few times, is there common software that you use for people that are curious just to like, I want to Google and just see what this looks like?
Yeah. So once again, building science is big, right? So if you're looking for like a hygrothermal, which is moisture and water, and so moisture, water, heat, I do WUFI, UWFI, which is a German group through Fraunhofer, and that's the program that I use. But there's other ones like Console, which is a CFD type of product, right? For people who don't know CFD, computational fluid dynamics or design. Stuff like that. So yeah, I mean, you kind of live in this real world, but some of them, like some energy programs are where building scientists live, right? So they can do like an energy analysis, or like in Revit or in like other CAD softwares. BIM is starting to become a big thing, right? I'm not saying anything new to you guys. You guys deal with BIM, but like building information modeling is starting to become a bigger thing, where now a lot of those new programs and other little additives add moisture potential analysis, right? Saying, hey, give me the conditions of your HVAC system, and I can tell you if you have condensation points, or that could be like a much more of a static analysis versus a dynamic one like the WUFI. But yeah, I mean, like it exists. Like there's a bunch of stuff out there, and to some of the people who are probably listening and deal with it, like this is nothing new. But for the people who don't, like there's a lot of programs out there that deal with it. SimScale's another one for airflow. That's a really cool one.
Yeah, that's pretty wild.
Yeah, and
I'm also surprised too when you said in the beginning, like it just kind of really clicked with me as you're going through this, of like, well, we went in there and the HVAC system was oversized, and it's like, man, how often do we hear, oh, you over-engineered it or whatever, but when does that actually become a problem? HVAC, humidity, and it's actually interesting to think about.
But think about it, right? So like not just structural engineers, and then you have commissioning groups, right, who go to an existing building and try to make it more energy efficient, whether it be like updating lights from incandescent to LED lights or LED. I like saying LED; it sounds fun. You know what I mean? But they also look at HVAC systems, and then now they're finally getting into envelope. I've actually know a couple like McKinstry and Energy Sense, where I was talking to them early on when I was at Owens Corning. I'm like, you have to focus on the envelope, because you're solving the high point of energy with HVAC systems. But if you're not air sealing and reducing the amount of infiltration that carries that moisture, you're not doing much at the end of the day. And sure enough, now they're getting into like those retrofit parts. And it all falls into the structure, right? Because it affects the way things are connected. Gaskets are bigger things nowadays, right?
Yeah.
Instead of free floating, bolted down steel beams, right? Like now there's a gasket required around there because they understand that air sealing and wind is an issue, right?
Yeah, absolutely. I've noticed too, I think it's the new 2021 energy code too. It's really started pushing the bounds of what needs to be done from a modeling aspect.
100%.
And what we've seen has changed is like it really it pushes you to not have a lot of windows, right? Because that's where a big amount of thermal is coming through the building. And so it's like instead of big curtain wall systems, sometimes it's more like smaller punched openings for smaller buildings, of course. So yeah, like you said, it's such a broad spectrum of what building science is.
Yeah, it is. And then now that you're thinking about it, you're like, oh, I have to think about this, right? And you're like, oh, that is building science. Because as soon as you start putting two dissimilar materials together, you're building. Like, yeah, that's it.
Yeah.
It becomes a topic for a lot of people that they don't realize that they live in that world. They just don't call themselves that, right? So to me, like, while I'm the doctor who finds out what's wrong, you guys are the specialists to tell them what's wrong with their bones, right?
Yeah. I like to stay with the bones. It's the easy doctor said.
So what questions have we not asked yet that you think are good questions?
That's a great question. There's a lot, and the reason why is because I've been dealing with this for forever. It feels like.
What I guess maybe in a different way, with all these conferences you go to, what are the big topics that are discussed? What are the things that are being solved, but what does the future look like?
Yeah. So AI is the big, scary 100-foot climb that no one knows what's going to happen, how it's going to be regulated. But there's going to be a lot of benefit, I believe, right? Because we can utilize that for AI to start planning where we're going to put our conduits for electricity or low voltage, right? Or even ducts, right? And then it's gonna go into understanding how the structure is, right? So all these things that are tied into them, where we naturally look at them as an individual issue, they're going to start being tied closer and closer together, especially when you have to have, like, let's say you're designing a hospital, right? And you have to have all these things coming into an operating room. But then that operating room has to be at 55 degrees to help prevent transmission of diseases, stuff like that at a moderately low RH, right? How does that affect the building, and how is it connected? Like, do you have to have specific boundaries into the interstitial space because that could be leaking in things, right? So like AI may help us solve a lot of these issues because we're so niche naturally that it can help us look at something broader.
Yeah.
So I just that's an example of something that's unique, but I've seen people use AI with like these little remote robots where it knows the plan, it knows where you are in the building, and it starts drawing where the walls are going to be, right? Like, yeah. So, but that's part of a combination of AI usage, maybe not a full version of AI, but it understands where it is, how it works, and then where it lays down the dots of here's where the walls are for the interstitial base, or here are like the boundaries for offices, right? It's going to start. And then like, I don't imagine why someone wouldn't be able to put up a projector and it look at a wall and be like, oh, I know what this wall is, and here's where your pipe is. So cut these holes here to put this pipe here so you don't mess up these other products.
Yeah. Yeah. We just did recorded an episode with some computer scientists in the structural engineering world. And we brought up AI because, that's the hottest topic everywhere, it seems like. And that's what they kept saying is like, there's so much value to be taken from it. And it's not going to replace the engineer or the person that's still got to make the decisions and think through how to do it. But it's just a tool.
Supplements, like,
yeah.
Just like any other tool we have.
Yeah. But no different, right? So when you guys are building structures or designing the depths, maybe that AI tools in the background saying, hey, don't forget, there's going to be this coming through here. So make sure you leave an orifice or design around it in this way. You know what I mean? Like just an added help to prevent future issues. And like, you have to understand that things in my head are going to like in my head, which is, the crazy part, but like we as a society are going to become more integral when we're building now. Like it's no longer going to be you do you I got here first, so I own the space. It's going to be like, oh, I only have this much space. I have to make the proper decision now. And like, it's going to trickle down to the trades, right? These trades are going to have to learn how to adopt it and implement these same tools that we're using, because you don't want to own an error when it wasn't your fault, right? Like that's always the issue.
Yeah.
If there is someone that's listening that wanted to get into more what you're doing with moisture mitigation and let's say that part of building science that we discussed, what kind of background do you think it would be best for them to be successful in having, or where should they learn more to become better into maybe entering that type of career?
I tell, so I'm going to give you a little better background. So I consider myself to be super lucky. Like, once again, I had a job leaving during 2010. I had a job. I was one of 8. I got into a company where I worked there for almost 11 years, and I got to explore and do whatever I wanted to do because they didn't know really what to do with me either. Right?
Yeah.
So I'm lucky, but there's a lot of people out there that can train you. There's good schools. Colorado School of Mines has a great building science program. Waterloo has a great building science program. You can partner with like national laboratories like ORNL here in Tennessee, all the way to NREL in Colorado, right? Or even be a Berkeley lab has a lot of building stuff where they put out these reports, right, where it affects how we use like you would not believe how much moisture is being done when you cook on your front burners versus your back burners that are typically under your vent.
Yeah.
Right? So like that kind of stuff, right? So like it depends on like how detailed you want to get. Like I love reading this stuff. It amazes me, and I'm just a guy who's learned how to connect it all. Like that's it. That's what I've done. Like nothing special about me, but I just connected dots that people will never think to connect. And that's what I do. But like if you want to get in on it, there's tons. There's HVAC companies that are now getting into that building science group. There's people you can follow like Allison Bales. He's on LinkedIn. He loves to publish how HVAC systems affect comfort, which affect building performance, which affect envelopes, right? These kinds domino, right? So, and he does both commercial and residential. So he has his own, consulting company. And there's tons. There's Energy Vanguard is the company, but like there's, Building Science Corp publishes monthly newsletters on new things that they've discovered or items that they're talking about or covering.
The one that popped up in my mind here when you brought up the burners and where you're venting from and stuff. What have you changed personally at your own house?
Oh, yeah.
That from what you've learned in your career.
Oh, that's no, I want. That's the problem is I do, and like, my poor wife, because like. I have sensors in my attic. I have sensors in my conditioned space. I monitor the CO2 levels in our house. I have warnings when it's too high, so I know when to open the door, right? So I'm constantly, a lot of people would say like death by data. Like there's not enough data that would kill me. Like give me all of it. You know what I mean? But like that's the issue is I love finding new methodologies. I'm hopefully going to be announcing a development of a new methodology for attic venting and stuff like that. So like that's what I'm working on in the background. So I love to experiment. My wife, she's very patient, but it's one of those things that I constantly I'm looking at things on how I would do differently or what I could do to improve later, and I've learned so much. And it's not like a me thing. It's like I really like learning from other people. There's a lot of smart people out there, and while I'll never hold up a candle to them, I'll fight for them. You know what I mean? Like I have no issues.
Definitely. Anywhere else you'd like to go or talk about? Or
no, I mean it's up to you guys. I know. Well, I know because I really want to try to focus it around structure because I that is so vital to what you guys do. And what
we talked a lot with Scott. Maybe this will help. Is like what's the things that we could know that's not structural that would be value added to an architect?
Yeah.
And so we talked about fire, and it's like structural engineers don't do a lot necessarily with it. It's mostly the architect.
Mm-hmm.
Or if we have the knowledge, like in sharing with the architects, we can be beneficial.
And when we review stuff, we can say, hey, that doesn't look like it would,
It's funny talking about like the what you should know. When I first started with Owens Corning, we were literally going around educating people how to follow the line. And if you know what I'm talking about as far as like an engineer, what that is you identify the WRB and you go from top to bottom, making sure it's properly shingled, making sure it's continuous, because you'd be surprised how many details they're so focused on, like a parapet, right? Making it look nice, but they don't identify how that parapet waterproofing material will integrate above the window properly. And then there's a big gap, right? So those are the things that I'd like to tell people. It's like, hey, look, if you're a structural engineer and you're looking at plans from an architect, give it an eye. Like, see if you can follow that line. See if you can identify the WRB from the top all the way to the bottom, or from like a 3-story building next to a 5-story building where they're touching. Well, how is that interconnection there? Because at the end of the day, if it's not done right, guess what? Water's going to be pouring in.
Yeah.
Right. So, and then guess who they call? They call the architect. Then the architect calls a specialist. And then they have to call the structural engineer, because was there damage to the structure? Did it start rotting out something? Did it ruin some sort of internal like rebar column? Stuff like that starts becoming a topic of conversation, right? So it never hurts to double check someone.
Yeah.
Because if you take the 10-15 minutes it's going to take you to follow that line down and making sure that it's a shingle, then you pretend your fingers to water and find its path out, you can identify problems early before you start building. Like, that's always what I tell people. I spend time reviewing, identifying other issues that you may not be as comfortable with, but something you can keep in the back of your head, because that's how you become better. You're challenging yourself, you're growing, but you're also preventing future issues and liability.
Yeah. There's definitely a lot of value, obviously, in just asking the question.
Yeah.
If you may not know how it works, like if I looked at a waterproofing detail, like I don't know exactly how this happens, but asking just the question for an explanation, like may point out a gap or something.
Yeah. It's funny. So my wife works at one of the local municipalities. She's a civil engineer. She has a master's in civil engineering. Water resources is her specialty. And they're building new tank covers, like the covers on top of like water treatment plant tanks. And she was like, Neil, like what is this top slab over foam? And I'm like, well, typically, you put foam down, and to protect the foam from UV, you put like a little floating slab, and it helps you can walk on it, stuff like that. And she's like, well, why would they put top slab under insulation? And I'm like, that's a bad detail.
Yeah.
That's a bad detail, right? So like, I'm not in that world, but once again, she's like, hey, I'm not comfortable. Why is there a vapor barrier here? And she just reach out to me, and I can consult. And mind you, I may learn something, but I've done enough building to where I immediately understood what she was talking about, and I knew what she was gonna be looking for, and I helped her identify some concerns. And it's funny, she went to the meeting. She texted me. It was happened today. She went to the meeting. She's like, they were dumbfounded I knew this stuff, and I'm like, great, because I helped her. I'm like, hey, look at this stuff. What are they going to be doing here? I'm like, this waterproofing kind of questionable, or why do they put a vapor barrier here versus here, kind of thing, right? So like those things that she doesn't deal in that world. These are plans that they hired someone to give to them, and now they have to approve the plan so they can move forward. And I'm over here like, why are they doing that? And she's like, that's a good question. And it's funny because even the engineer was like, yeah, I don't know. Like that was some of the answers. It's like, oh, that's a bad detail. You're right. We'll fix it. Or yeah, I don't know why we're putting that there. You know what I mean? Just because no one asked them or no one challenged them.
Yeah.
I really like civil engineers in their redlining waterproofing details. I feel like I should try that sometime.
Yeah.
Yeah. Well, cool. Well, Neil, thank you so much for being on the podcast today. Really appreciate it.
Yeah, no, thank you for having me. I really appreciate it. And if people want to know more about LP, lpcorp.com. If people want to find me, I'm not great at social media. I'm a nerd. I'm sorry. But BS with Neil, Building Science with Neil, on Instagram, if you want to ping me, ask questions.
We'll put in the show notes, links.
Awesome. Thank you so much, guys.
Thank you.
Thank you.